Hi everyone. In this video, we're going to be doing A-level further maths 9231, paper 24 for the pure maths 2 major 2025. This paper is 2 hours long, so we'll try to finish within the time limit. So let's head on to the first question. Okay, so to do this first question, for the first part, it told us to find the values of k for which the system of equations, so this equation right here, does not have a unique solution. Okay, so what do they mean by not having a unique solution? So that basically means that X, Y, and Z, they don't have like just one set of values. Either they have infinitely many solutions or no solutions at all. So if that happens, yeah. Okay, you know what? First, let's express this in a matrix. So the standard procedure to solve a system of equation using matrices is you take the coefficients of x, y, z. So we take the first equation first, the coefficients. So we have 1, 2, 3. And then for the second row, we have k, 5, 6. The next one, we have 7, 2k, and 9. And then we multiply it by x, y, and z, whatever the variables are that you want to find out, and then you equate it to a matrix consisting of the answers on the opposite side. So in this case, it's 1, 2, 3. Okay, so to solve a system of equations like this and to get a solution for x, y, and z, you have to take the inverse of this matrix. So in other words, if a system of equations doesn't have a unique solution, that means you cannot take the inverse of this matrix. And that only happens when the determinant of this 3 by 3 matrix is equal to 0. So let's find out the determinant, okay? So determinant multiply by 1, you carve up the row, you take the um, cross product of this, so 5, 6, 2, k, 9. Okay, let me just erase. Okay, then after that you multiply by 2, but instead of a plus sign, put a minus 2. And then yeah, you cover up the rows and columns that have the 2 inside, and then you take the determinant of the remaining elements. So in this case, it's k, 6, 7, 9. And then after this, we're going to repeat it for the last element, which is 3. So now you plus 3, multiply by the determinant of the remaining elements. So in this case, it's k, 5, 7, 2k. Okay, let's evaluate this. So 1 times anything, that's just 1. So we can leave this alone. So just have to evaluate this determinant. So to do that, cross multiply. So 5 times 9, 45. And then you minus the other cross product. 6 times 2k, that's minus 12k. Okay, and then minus 2 times again cross product. So k times 9, that's 9k. Minus 6 times 7, that is 42. And then let's do the same for this. So 3 times k plus 2k times 2k, that's 2k squared. Minus 7, 5 times 7, that is 35. So let's expand and simplify as much as we can now. So minus 2 times 9k, that's minus 18k. Minus 2 times minus 42 is what you call 84. 3 times 2k squared, 6k squared, and 3 times 35. You get minus 105. So let's collect all the terms together. So let's put the k squared term first, then all the k terms, so minus 12k, minus 18k, you get minus 30k. And then the constant term 45 plus 84 plus minus 105. Okay, that's all. 24. Perfect. Okay, now as I said, if you no unique solution, then there's no inverse. So you have to equate it to zero now, and the determinant. And now we can solve for k. Yeah, so you see it's a quadratic equation. I'm not going to go over much. So just simplify your coefficients. Okay. Um, we're supposed to get k minus 1 times k minus 4. Yeah. Yep. Yeah. So just equate these two to 0. You'll get k equals to 1 and k equals to 4. Yeah, they said values of k. So these two are our final answers, 1 and 4. Let's head on to the next part. Okay, so for this second part, we're told to consider the case where k equals to 1. We have to show that for that case, system of equations in part A is consistent. So what do they mean by consistent? So it basically means that they they have infinitely many solutions. Okay, so yeah, we have to show that, and then we have to also interpret the solution geometrically. So by geometrically, they mean we're supposed to think like in terms of the equations of planes. Okay. All right. So let's substitute k equals to 1 to the system of equations. So first equation stays the same. Yep. X plus 2y plus 3z equals to 1. Next one, ax. So that's still just x plus 5y plus 6z. So 5y plus 6z is equals to 2. And then 7x plus 2ky. So 7x, 2ky, that's 2 times 1y. So just 2y. And then you have plus 9z equals to 3. Okay, so let's see what we can do. So, how do we show that this is consistent? Okay, how about this? Let's take equations 1, 2. Since they have like x in both of them, we can do 1 minus 2 to get rid of the x term. Actually, let's do 2 minus 1. Okay, so this x cancels out, then 5y minus 2y, you get 3y, and 6z minus 3z, you get 3z. 2 minus 1, you obviously just get 1. So yeah, this is equation number 3. Okay, and then now we need the second equation in terms of y and z. Okay, so let's take this equation number 4, and then let's multiply equation 1 by 7, and you get 7x plus 14y plus 21z equals to 7. I think, okay, we call this equation 5. Okay, all right, so now 5 minus 4, you get 14y minus 2y, you get 12y. 21z minus 9z, you will get 12z. And then 7 minus 3, you get 4. And then we can further simplify, just divide everything by 3. So you get 3y plus 3z equals to 1. Yeah, so as you can see, Um, yeah, both, we can write now both equations derived, derived are exactly the same. So that means there's infinitely many solutions. Hence, system of equations is consistent. And infinitely many solutions. Infinite solutions. Yeah, so since like when we derived our equations, we got the same equation. Um, that means there must be like a common line that passes through all of them and they're intersecting at that line. So imagine we have this plane and then another plane. So I know it's a bit hard to see, and then another plane, and then there's a line passing through each other. So from the front, it will look like this, and then the line is coming like towards the screen. Okay. Yeah, so this is the geometric interpretation. So we can say planes have common, okay, all three planes have a common line that they are intersecting at all points. Yeah, so as you can see, I'm trying to be as detailed in here as possible. Yeah, so this is our final answer. Okay. So yeah, one final note is that please be as detailed as you can with your solution, especially your interpretation. Okay. Yeah. Always be safe. And with that, let's head on to the next question. Okay, so for this question, we are told to find the exact value of this definite integral. Told us to give an answer in a logarithmic form. Okay, so to start off, um, let's write down our integral. Okay, so as you can like see, in our integral, it's a quadratic that is under a square root. So whenever you see such an integral, your first instinct would be to complete the square for the quadratic. So let's do that. Okay, so 1 over, so yeah, the coefficient of x squared is 1, so we can just straight go ahead. So x, yeah, since minus, we put minus 2 divided by 2, that's 1, so 1 squared, minus 1 squared, so minus 1 squared plus 5, so minus 1 plus 5, that is plus 4 dx. Okay, and now our next step would be to choose a suitable substitution. So in order to do that, let's check out the formula sheet and look for the integral that is in this general form. So this is like x squared plus a squared square root over 1. So we should look for this in our formula sheet. Okay, so let's go ahead. So go on to further pure maths. Okay, let's see. Okay, yeah, x squared plus a squared. So this is the form that we're looking for. So as you can see, the integral is sine inverse x. So immediately the integral for the standard integral should already like give you a clue that you're supposed to use either cosine or sine. Okay, let's use sine. Okay, yeah, let's substitute sine. So we'll let x minus 1 equal to yeah, 2 sine, because like when you square 2 sine u squared, you get 4 sine u, sine square u plus 4, then you can factorize the 4. Okay, so I hope it's clear. Okay, now we are going to differentiate, so isolate the x, and then find dx du. So this one goes away, and then 2 sine u, you just get 2 cos u. And then dx will get 2 cos u du. Okay, and then since we're using a substitution, we should also change the limits. Okay, so let's isolate u. So sine u is x minus 1 over 2, and then u is sine inverse x minus 1 over 2. So u upper limit, sine inverse x minus 1 over 2. So 5 over 2 minus 1 divided by 2, you get sine inverse 3 over 4. Yeah, so to find the exact form, go to your formula sheet. There's an expression for sine inverse x in terms of ln. So we're going to use this ln x plus square root x squared plus 1. Okay, so it's going to be ln x. So x is 3 over 4 plus x squared. So 3 over 4 square plus 1 square root. Yeah, you'll get a very nice answer of 2. So this is our upper limit. Now the lower limit, you just get sine inverse 1 minus 1 over 2. That's sine inverse 0. So you just type into your calculator sine, sine inverse 4. Yeah, you just get 0. Yeah, so we have done our integration by substitution. Now we're ready to change this. So upper limit is ln 2. Lower limit is 0. 1 over, like I said, x minus 1 squared. You get 2 sine u whole thing squared. So that's 4 sine square u. So 4 sine square u plus 4 dx. Oh wait, this dx is supposed to also replace, so times 2 cos u du. And then you get ln to 0, 1 over, you factor out square root 4, you get 2, and then square root of 1 plus sine square u. Yeah, you can see here, you make 1 plus sine square x, you'll just get cosine square x. And square root of cosine square x is just cosine u times 2 cos u du. So you cancel, and then you just have to integrate 1 with respect to u. So you just get u. With these limits, you just get ln 2 minus 0, that's ln 2. So this would be our final answer for this entire question. Okay, so yeah, one final tip to do this type of question. If you get like quadratic in a square root, complete the square and then see what form it fits in the formula sheet. Then you see the result, and using the result, you choose a suitable substitution. Okay, yeah, so that's the general tips. And with that, let's head on to the next question. And you can also use a calculator to check if you can. Okay, so for this question, we are told to find the particular solution of this dE. So you can see that this dE is a second order non-homogeneous dE. And then we're also given the initial conditions, that y equals to 1, dy dx is 0, and x equals to 0. Okay, so to solve this type of differential equation, you're first gonna have to derive your auxiliary equation. So it's very simple. So the second derivative, you replace it with lambda squared, and then dy dx, first derivative, it's just lambda. And then the constant term, I mean, the term in y, that would be a constant term, and you equate it to 0. Okay, now use your quadratic formula to solve for this. So minus b, that's minus 4, plus minus b squared, that's 4 squared, that's 16, minus 4 times 8, which is 1, and then c, that's 5 over 2 times 1. Yeah, so you can see that the square root, you get 16 minus 20, which is minus 4. So you're not going to get real solutions, unfortunately. But don't worry, there is a way to derive the general formula. Yep, I was right. So lambda 1 is minus 2 plus I, and lambda 2 is minus 2 minus I. Yeah, so these are values for lambda. Now we are going to derive our complementary solution. Okay, so complementary solution is going to be equals to y is equals to a times e to the power of what your solutions, the lambda. So that for us that would be minus 2 plus I, and then plus b e to the power of minus 2 minus I. Okay, so as you know, we cannot leave the answer in this form. So what we can do is we first decompose this exponential into multiples. So like we're going to use our indices laws. So, you know, a to the power of m plus n, you get am times a to the power of n. So we're going to use this. So hence this would be e to the power of negative 2 times e to the power of I. Oh, wait. Oh, wait, sorry. You're supposed to add x. You're supposed to multiply x to the power. Yeah. Yeah. So, and then this would also be to the power of x. Okay. Let's also do the same for that. So I get minus 2x times e to the power of minus I x. Okay. So let's simplify everything. So this becomes e to the power of minus 2x times e to the power of ix plus b times e to the power of minus 2x times e to the power of minus ix. Okay, and then for this, to evaluate this, we can actually use our Euler's identity. Wait, this is, yeah, Euler's identity. So this would just be cosine x plus I sine x. And then this one would be, so we can actually move this negative 1. So this just become e to the power of ix, the whole thing to the power of minus 1. So this just becomes cosine x plus I sine x to the power of negative 1. So this negative 1, you can recall your Demav's theorem, and then you can spread it to the coefficients of x in cosine and sine. Yeah, so let's expand this first term out. So yeah, sine x plus a I e to the power minus 2x sine x b e to the power minus 2x. So cosine minus x, that's the same as cosine x. And sine minus x, that's the same as minus sine x. So this is minus b e to the power minus 2x sine x. So we can like just group the terms together and we can combine the coefficients. Yeah, so a plus b, we can just write it as c times e to the power minus 2x cos x. Then as for this and this, oh shoot, I. Yeah, so yeah, if you combine this will just become real. Okay, so minus 2x times x. Yeah, so this is our final auxiliary equation. You don't have to do this derivation if you can just memorize, but for me, I cannot memorize. I prefer to derive it. Yeah, so this is the auxiliary equation. Now we are going to find our particular integral. Okay, so to find your particular integral, you have to see what is on your right-hand side of the dE. So you can see it's 13 times e to the power 3x. So that would give us a clue on what we should let our y be. So we have to let our y be equals to a constant multiplied by e to the power of 3x. Yeah, so that's one of the rules. So let's let y be that. And now you will find your dy dx and your second derivative. So you move the power over. So 3a e to the power of 3x, and then second derivative 3 times 3, 9a e to the power of 3x. All right. Now we can substitute into our dE. So 9a e to the power of 3x plus 4 times dy dx. So 4 times 3a, so that's 12a e to the power of 3x plus 5y, so 5 times a, 5a e to the power of 3x equals to 13 e to the power of 3x. So we can just factor e to the power of 3x and then just add up the coefficients. So 21 plus 5, you get 26a e to the power of 3x equals to 30 e to the power of 3x. So we can cancel the e to the power of 3x and just divide both sides by 26. We get 13 over 26, which is 1 over 2. So it's half. All right. Yeah. So hence our particular integral is equals to y equals to half e to the power of 3x. Yeah, so now we can find our general solution. So general solution would be a complementary solution plus your particular integral. So general solution would be y equals to auxiliary equation, general complementary solution. So c e to the power of 2x cosine x plus d times e to the power of 2x sine x plus particular integral, which is half times e to the power of 3x. Yeah, so this is our general solution. Now we can substitute the initial terms, the initial conditions. So we can sub y equals to 1 and x equals to 0. So sub y equals to 1, x equals to 0. So c times e to the power of 0, that is c times 1, so just c. And then cosine 0, that is 1. So c times 1 plus d times e to the power of 0, that's d times 1. And then sine 0, that is 0. So anything times 0 would just be 0. And so half times e to the power of 3 times 0. So e to the power of 0, that's 1. So half times 1, you just get half. And this is equals to y equals to 1. Yeah, so easily we can just see that c is 1 minus half. So you'll get half. All right. Now to get d, we are going to have to use the other set of initial condition, y equals to 1 and dy dx equals, wait, no, sorry, dy dx equals to 0 and x equals to 0. So hence we are going to differentiate. Okay, so first we're going to differentiate this term. So to do this, you just ignore the c first, so you keep it outside, and we're going to use the product rule to differentiate e to the power of minus 2x times cosine x. So I will differentiate e to the power of minus 2x first, so that's minus 2 times e to the power of minus 2x cosine x. And then now I'm going to keep the first one and differentiate cosine x, that is minus sine x. Yeah, minus sine x times e to the power of minus 2x. So minus e to the power of 2x sine x. Okay, and now plus d. So now we differentiate this. So you again keep the d out and you just differentiate e to the power of minus 2x times sine x. So I'll keep e to the power of minus 2x first and differentiate sine x, so cosine x, plus differentiate e to the power of minus 2x. So that for that you get minus 2 times e to the power of minus 2x, and then you keep sine x. And now you differentiate this, half times e to the power of 3x. So to differentiate, you take a power, differentiate it, and you multiply it by the whole expression. So derivative is 3, so multiplied by 3, you will get 3 over 2 times e to the power of 3x. All right, now we're going to sub dy dx equals to, let's check, 0, and x equals to 1. Okay, so c is, we already know what c is, so half minus 2 times e to the power of minus 2 times 0, so that's just minus 2 times e to the power of 0. E to the power of 0 is 1, so 2 times 1, that is minus 2. Minus 2 times cosine 0, cosine 0 is 1, so it's just minus 2. So minus 2 times e to the power of minus 2 times 0, that is e to the power of 0, that is 1. So minus 1 times sine 0, you just get 0. Yeah. So minus 2 minus 0, that's just minus 2. Okay, and then plus d times e to the power of minus 2 times 0. That's e to the power of 0, that's 1. 1 times cosine 0, that is also 1. So 1 minus 2 times e to the power of 0, that is 2 times 1, so 2. And then sine 0, that's 0, so it's just gone. So we only have 1 here. Okay, plus 3 over 2 times e to the power of 3 times 0. That's e to the power of 0. That's just 1. Yeah, so just 3 over 2. And that's equals to dy dx equals to 0. So this cancels out. So we have minus 1 plus d plus 3 over 2 equals to 0. Hence, d would just be 1 minus 3 over 2. So 1 minus, 1 minus 3 over 2, you get minus half. Yeah, so these are our constant terms. Now we can finally write our particular solution. So it's y equals to c. So c is half times e to the power of minus 2x cosine x, and then plus d, which is minus half times e to the power of minus 2x sine x plus half times e to the power of 3x. Yeah, so this will be our final answer for this entire question. Let's head on to the next question. Okay, so for this question, we're told the curve has these parametric equations. Yeah, so this and this. And for the first part, we have to show that 1 is the only real value of t for which x equals 0. Okay, so let's equate the x expression for x in terms of t equals to 0. So let's try grouping. So let's factorize this first. So get t squared times t minus 1 plus t minus 1 equals to 0. So as you can see, we have a common factor here. So this is just 1 times t minus 1. So factor of t minus 1, this would be times t squared plus 1 equals to 0. As you can see, we no longer can factorize further, so we just equate both sides to 0. So t minus 1 equals 0, we get t equals to 1, and t squared plus 1 equals to 0. You get no real solution. Yeah, because t squared cannot be minus 1. Yeah, so yeah, we have managed to show that 1 is the only real value. So we can write shown here. Yeah. So yeah, let's head on to the next part. Okay, so now we need to show that dy dx is equals to this whole expression. Okay, so to find dy dx parametrically, let's state the formula. So dy dx is just dy over something times something over dx. So this something must be equal, then they will cancel each other out. So obviously this is just dt, and times dt over dx is the same as saying dy dx, dy dt divided by dx dt. Yeah, so let's find dy dt first. So let's take our y expression. So y is equals to t times e to the power of t, and then dy dt. Use the product rule, so let's keep t first and differentiate e to the power of t. That's just e to the power of t, and then plus e to the power of t. We keep that times the derivative of t, so that's just 1. So that's e to the power of t. Okay, now we factor out e to the power of t, you get t plus 1 times e to the power of t. Okay, and now find dx dt. So, so x, so x is t cubed minus t squared plus t minus 1. Okay, so dx dt, you just differentiate them separately. Okay, oh goodness. So this becomes 3. Okay, no, I wasn't recording for a while in here. Okay, so as I was saying, yeah, this is t squared, and then t squared differentiated is just minus 2t, and plus t, that's just 1, and then minus 1, you just get 0. So now, yes, oh my goodness, it's still quite like uh, equals dy dt, so that's t plus 1 times e to the power t. Oh my goodness. Sorry, something's it's pretty laggy right now. To the power t. Okay. To the power t divided by dx dt, so that's 3t squared minus 2t plus 1. Yeah, so yeah, you can see that it's exactly the same as the answer that we've been told to show. So we can write shown. So we are done here for this part. Let us head on to the next part. Okay, so here, this last part, they told us to find the Maclaurin series for y up to and including the term in x squared. Okay, so let's look at the formula for a Maclaurin series in general. Okay, wait, I'm in the wrong section. Yeah, so Maclaurin series is here, and this is the formula that we have to use. So the question only told us to include the term up to x squared. So we just need to find up until here. So this is the only portion. So yeah, let's write it down. So fx is equals to f0 times x f prime 0 plus x squared over 2 factorial f prime zero, like the second derivative when you substitute x equals to 0. Yeah, so let's find f x equals to 0. Okay, so to find it, um, so the problem is that our function, the y function, so okay, let me just write down. So y is t times e to the power of t. So as you can see, our y isn't a function of x, rather it's a function of t. So in order to find f0, yeah, we're gonna have to use the value of t for which x equals to 0. So in our case, we already proved in the first part that only t is equals to 1 when x equals to 0. So we're gonna have to write down ft equals to 1. Yeah, so to find f0, we're going to take this f0, t that's 1 times e to the power of t, so that's just e. So that's f0. Now let's find f prime 0. So again, we have to substitute t equals to 1 since our f prime dy dx is in terms of t, not in terms of x. So we substitute 1. Okay, so f prime 0, t plus 1, that is 2 times e to the power of t, that's e to the power of 1, over 3t squared, that is 3 times 1 squared, that's 3, and then minus 2 times 1, so minus 2 and plus 1. Okay, and then you get 3 minus 2, that's 1, 1 plus 1 is 2, so 2 over 2 is just 1, so you just get E. Oh. Mm. Okay, and now we need to find this But the problem is we don't have an expression for d squared y dx squared, the second derivative. So we're gonna have to evaluate that first. So let's do that. So the definition, we start with the definition first. So it's just the derivative of the first derivative dy dx. But we know that our dy dx is not in terms of x, so we have to differentiate with respect to t. And following the chain rule, we also have to multiply with dtx over dx. And this is the same as dt dt over times dy dx divided by dx over dt. So d squared y dx squared, you have to differentiate your dy dx, which is pretty tough. Okay, yes, t plus 1 to the power of e to the power of t over 3t squared minus 2t minus 2t plus 1 divided by dx dt. So divide by dx dt, that's the same as multiplying by the reciprocal of dx dt. So times 1 over 3t squared minus 2t plus 1. All right, so let's differentiate this one. So let's use the quotient rule. So let's square the denominator. And now we keep the denominator in the numerator. And we multiply by the derivative of the numerator. So you can see it's a product, so use the product rule. So let's keep t plus 1 first. So just get t plus 1 times e to the power of t, and then plus, now we keep e to the power of t and differentiate t plus 1. That's just 1, so e to the power of t. Yeah, and then we minus the derivative of the denominator. So 3t squared, you get 6t minus 2 times t plus 1 times e to the power of t. Yeah, so and then times 3t squared. Yeah, so this one will just be cubed. Let's simplify further. Okay, so 3t squared minus 2t plus 1. Oh, shoot, okay. We have to make use of the limited space. So this becomes t plus 2 times e to the power of t. Okay, minus t minus 1 t minus 2 times t plus 1 e to the power of t over 3t squared minus 2t plus 1 cubed. Yeah, so this is our expression for the second derivative. Now we're gonna find our f double prime 0. So again, since our function, the second derivative is in terms of x, we cannot substitute t equals to 0. Instead, we need to substitute t equals to 1 because that's the value of t, but that gives us x equals to 0. So let's just do this using the calculator. So this one, you get 3 minus 2 plus 1, that's just 2 times 1 plus 2, you get 3 times e to the power of t, that is also e, then minus 60 minus 2, that is 6 minus 2, times 1 plus 1, that's 2, so that's minus 8 times e to the power of 1 over you get 3 minus 2 plus 1, so 2 cubed, so that's just 8. Yeah. So 6e minus 8e, you get minus 2e over 8. So you will get minus 1 over 4e. Okay, now we can finally derive our Maclaurin series. So fx is f0. So that's just e plus x times f prime 0. So x e and x squared 2 factorial. So x squared 2 factorial minus 1/4 e. So simplifying, you get e plus xe minus 1 over 8 x squared e. Yeah, so this would be our final answer for this last part, as well as the entire question. Let's head on to the next question. Okay, so for this question, for the first part, we have to use Demav's theorem to show that this result is true. Okay, so there is two versions of Demav's theorem that we are required to use, and we have to choose one depending on what the question is asking. So in this case, we have to express sine m theta, where m is an integer, in terms of powers of sine. So sine to the power 7 and so on. So if you have to derive this some expression, like let's say cos n theta, you have to express in the sum of cos to the power of z theta plus cos to the power of y theta and so on. You're gonna have to use this identity, cosine theta plus I sine theta to the power of whatever the coefficient of theta is. So in this our case, it's 7. So you have to first expand this using the binomial expansion, and then you use your Demav's theorem and you spread the powers in terms in front of the thetas. Yeah, so then this is also equal to cosine 7 theta plus I sine 7 theta. Okay, so let's start the binomial expansion. Okay, so to do the binomial expansion, I'm just going to use the Pascal's triangle for the coefficients. So this is 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So 2, 3, 4, 1, 5, 10, 10, 5, 1. Okay, and the next one, 1, 6, 15, 20, 15, 6, 1. So 1, 2, 3, 4, 5, 6, 7. Okay, next one. It's going to be our row. So 1, 7, 21, 35. 2 plus 15. So get 35. 21, 7. Yeah, so this is going to be our coefficients for the 8 terms that we'll have. All right, so yeah, first term, coefficient is 1. First term is going to be cosine to the power of, it's cosine theta to the power of 7. And then plus 7 times cosine to the power of 6 times I sine theta. And plus 21 cosine to the power of 5 theta times I sine theta squared plus 35 cosine 4 theta times I sine theta cubed plus 35 cosine to the power of 3 times I sine theta to the power of 4, then plus 21 cosine square theta times I sine theta to the power of 5 plus 7 cosine theta times I sine theta to the power of 6 plus I sine theta to the power of... Okay, so now we're gonna get cosine theta to the power of 7 plus 7 I cosine power of 6 plus I sine theta. And then to simplify this, we can just transfer the powers to I and sine theta. So you get I squared times sine theta squared. And I squared, we know, is just equals to -1. So this one will just be minus 21 cosine theta to the power of 5 sine squared theta. Okay. And now, right, so, right, and then next one, plus 35. Okay, so for this again, you can shift the powers. So we have I cubed times sine theta cubed. So I cubed is just I squared times I. So that is -1 times I. So just minus I. So this one would just be minus 35 I cosine theta to the power of 4 times sine cube theta plus 35 cosine cubed theta sine theta to the power of 4. Because again, shift the powers, you get I to the power of 4 and sine theta to the power of 4. And I to the power of 4 is just I squared squared. That's just -1 squared. And you get... Okay, and then as for this, you get I to the power of 5 and sine theta to the power of 5. And I to the power of 5 is I to the power of 4 times I, that is 1 times I, so it's just I. So this is plus 21 I cosine square theta sine 5 theta. And then this one, okay, wait. So you get I to the power of 6 and sine theta to the power of 6. And I to the power of 6 is the same as I to the power of 4 times I squared. So this is 1 times -1, so I get -1. So this one is -7 cosine theta sine to the power of 6 theta. And then finally, you get I to the power of 7 and sine theta to the power of 7. So I to the 7 is just -1 times I. So this is just minus I sine theta to the power of 7. Okay, and now let's separate the real and imaginary terms. So real, we have cosine theta to the power of 7 minus 21 cosine theta to the power of 5 sine square theta plus 35 cosine theta cubed sine theta to the power of 4 minus 7 cosine theta sine theta to the power of 6 plus I times 7 cosine theta to the power of 6 sine theta minus 35 cosine theta to the power of 4 sine cube theta, oh my, plus 21 cosine theta squared sine theta to the power of 5 minus sine theta to the power of 7. And then we can obviously equate this to this. So yeah, just spread the powers. So you'll get cosine 7 theta plus I sine 7 theta. Okay, now you can equate sine theta to the imaginary part. Okay, so hence sine 7 theta is the same as 7 sine theta times cosine to the power of 6 theta. So cosine to the power of 6 theta, we can re-express it as cosine squared theta to the power of 3 minus 35 sine cube theta times cosine to the power of 4 theta. So you can express it as cosine squared theta squared, and then plus 21 sine to the power of 5 theta cosine squared theta minus sine to the power of 7 theta. Okay, so there's enough space left. Okay, so we better do this in a short amount of space and we expand. Okay, so cosine squared theta is the same as 1 minus sine squared theta. So 1 minus sine squared theta to the power of 3, and use the Pascal triangle that we sketched earlier. So this will be the coefficients 1, 3, 3, and 1. So first term will be 1 cubed plus 3 times 1 squared sine squared. So that's plus 3 sine squared. Yeah. And then you have plus 3 times, wait, sorry. Yeah, so sorry, this is supposed to be a minus sign. And then you have times 3 times 1 times minus sine squared squared. So that's sine 4. Okay, so what's that? Sorry. Oh my. So yeah, plus 3 sine theta to the power of 4. Yeah. Minus minus sine cube. So sine squared cube, you will get minus sine theta to the power of 6. Okay, now let's do the same for that one. So yeah, again, we have to, this is 1 minus sine squared theta, and 1 minus sine squared theta squared. That is 1 minus 2 times 1 sine squared theta, that's minus 2 sine squared theta, plus sine squared theta squared, that's sine theta to the power of 4. Okay. All right. And then also this one, we can write as 1 minus sine squared theta. So yeah, let's just directly expand. So 21 sine theta to the power of 5, 21 sine theta to the power of 5 minus sine squared theta, that's minus 21 sine theta to the power of 7 minus sine theta to the power of 7. Okay, now let's collect all the sine theta to the power of 7 terms. So we have 7 sine theta times minus 6 sine theta. So that is minus 7 sine theta to the power of 7 minus 35 sine cube theta times sine 4 theta. You get minus 35 sine theta to the power of 7. And then you have minus 21 to the power of the sine theta to the power of 7 and minus 1 to the power of 7. Then you get actually yeah, to make this simpler, let's just expand everything out. Okay, so 7 sine theta minus 21 sine squared theta plus 21 sine 5 theta minus 7 sine theta to the power of 7 minus 35 sine cube theta plus 70 sine 5 theta minus sine 35 sine theta to the power of 7 plus 21 sine theta to the power of 5 minus 21 sine theta to the power of 7. Okay, wait, let me check. Okay, yeah, to the power of 7. Yeah, so let's now add the terms again. So minus 7 sine theta, minus 35, minus 21, and minus sine 7. Okay, so minus 7, minus 35, minus 21, minus 1. I get minus 64 sine theta to the power of 7. The next term is sine theta to the power of 5. So you have 21 sine theta to the power of 5, 70 sine theta to the power of 5, and 21 sine theta to the power of 5. Okay, so 21 plus 70 plus 21, get plus 112 sine theta to the power of 5. Okay, and then you have, what else? Okay, wait. Oh, sine cube. Sorry, the sine cube. So you have minus 21 sine cube minus 35 sine cube. So minus 21 minus 35. You get a minus 56 sine theta cube. Okay, and then you have 7 sine theta. Yeah, plus 7 sine theta. Yep, so this is our final answer. And as you can see, it exactly matches our given result. So we can write shown. Yeah, so with that, let's head on to the next part. All right, so for this part, it told us hence, so they're implying that we have to use the result that we derived in the previous part. We need to find all roots of this equation in this form, sine q pi, where q is a rational number. Okay, so for this type of question, your first instinct would be to substitute x equals to sine theta. Okay, sine theta. And then you change your equation accordingly. So 64 sine 6 theta minus 112 sine 4 theta plus 56 sine square theta minus 7 equals to 0. Yeah, as you can see, the coefficients are very similar to our result that we have derived. Okay, it's very similar. So yeah, the only difference is that it's not minus 64 and the powers are all less than 1. So now to rectify that, let's multiply both sides of the equation by minus sine theta. So you'll get minus 64 sine theta to the power of 7 plus 112 sine theta to the power of 5 minus 56 sine cube theta plus 7 sine theta would be equals to 0. Yeah, so now it is exactly equal to this. So we can just write sine 7 theta is equals to 0. Okay, so to solve this equation, we just have to find values of 7 theta and exactly how many values there should there be. So in our original equation, the highest degree is 6, and you should know, like from A-level maths, that if the highest degree is like n, then there should be n solutions. So hence, we have to find 6 solutions for 7 theta. So let's do that. So obviously, first solution is 0. And then the next one is going to be what? Pi. Yeah, pi. And then we have 2 pi. Yep, 2 pi. And then we have 3 pi. Then I believe we have 4 pi. Okay, that's 5 solutions. So one more is 5 pi. Okay, let me just double check using the calculator. So yeah, sine pi is also 0, sine 360, yeah, that's 0. Radian 3 pi, sorry, 3 pi, yeah, 0. 4 pi, 0. 5 pi is also 0. Yeah, so, hmm. Okay, let's try sine negative pi. Yeah, we can also write negative pi instead of 0. Just to be safe, because like if you put 0, then you just get 0. But they didn't. They told us not to write it. We must write it in this form. So I chose negative pi instead. Wait. Wait, what? Hmm. Okay, what? Let's not write negative pi. Uh, yeah, I don't think 0 would also be a good fit. Yeah, so yeah, let's write 6. Instead, 6 pi. That also works. Yeah, so now just divide everything by 7. So pi over 7, 2 over 7 pi, 3 over 7 pi, 4 over 7 pi, 5 over 7 pi, and 6 over 7 pi. So these are the values of theta, and now we can find the values of x. So we have sine theta. So sine pi over 7, sine 2 over 7 pi, sine 3 over 7 pi, sine 4 over 7 pi, sine 5 over 7 pi, and finally sine 6 over 7 pi. Yep, so yeah, this our roots for this equation. Yeah, there should be 6 roots. Okay, and with that, let's head on to the next question. Okay, so for this question, we're told to find the solution of this differential equation. So you can see it's a first order differential equation. And then we're also given the initial conditions, y equals to pi over 2 and x equals to 1. And we're told to give our answer in the form y equals to fx. So we have to make y the subject at the end. Okay, so to do this question, we first make the coefficient of dy dx equals to 1. So we have to divide both sides by x. So dy dx minus y over x equals to 2x tangent inverse x. Okay, and then now we need to find our integrating factor. So the integrating factor is basically what we have to multiply by on both sides of the equation in order to get our left-hand side in this form, f prime x gx plus g prime x gx. And then we can use the reverse product rule and integrate it. Then we just get fx times gx. Yeah, so this is the main principle behind it. Okay, so to find integrating factor, you take e to the power of integral of the coefficient of y. So in our case, it's minus 1 over x dx. Okay, and then you can remove the negative sign. So negative integral of 1 over x dx. So you get e to the power of minus ln x. Okay, so this is the same as 1 over e to the power of ln x, and e to the power of ln x, just 1 over x. Okay, so yeah, we have to multiply 1 over x on both sides. So you get 1 over x times dy dx minus y over x squared. This is equals to 2x over x, that's 2 tangent inverse x. Okay, so yeah, as you can see for this part, we have dy dx, and this is fx, and minus 1 over x squared, that is our f prime x. So this is in our product rule form. So we can use reverse product rule and say this is the derivative of y over x. Then this is equals to 2 tangent inverse x. So integrating this, you just get y over x equals to the integral of 2 tangent inverse x. So now we need to integrate this. So to integrate this, we need to use integration by parts. There's no other way. So we have to let one of them be u and one of them be dv dx. So to decide which one we need to let be u, we're going to use lit, okay? So log inverse algebraic trig and exponential. So we, in our case, we have inverse and algebraic, and whichever comes first in our list, we have to make that equals to u. So we have inverse come first, so hence we're going to make tangent inverse x be equals to u. So yeah, so to do this, we first take u times v. So v is the integral of dv dx. So dv dx is 2. So integrate that, you get 2x. So this is 2x tangent inverse x minus v times du dx. So v is 2x times the derivative of tangent inverse x, and it's given in your formula sheet under the standard results. Yeah, it's just 1 over 1 plus x squared. So 1 over 1 plus x squared dx. So this is 2x tangent inverse x minus 2x over x squared plus 1 dx. Okay, so to integrate this, first notice whether the power of the numerator is 1 less than the power of the denominator. So in our case, this degree is 2, and the power of this degree is 1. So it's just 1 less. So we can express it in the form f prime x over fx. If you integrate this, just get ln fx. We can see that's already in this form. Like you differentiate x squared plus 1, you will get 2x. So this is just ln x squared plus 1. Okay, and don't forget your plus c. Okay, so hence we can write y over x is equals to 2x tangent inverse x minus ln bracket x squared plus 1 plus c. Okay, now let's substitute our initial conditions. So sub y equals to pi over 2 and x equals to 1. So pi over 2 divided by 1, that's just pi over 2, equals to 2 times 1, that's 2 tangent inverse pi no, tangent inverse 1, sorry, minus ln 1 square plus 1. That's 2 plus c. So c, you will get pi over 2 plus ln 2 minus 2 times tangent inverse 1. So tangent inverse 1, you get pi over 4. So this one is minus pi over 2. So this also cancels out. So you get ln 2 as well for C. Yep. Okay. So you can write down y over x is equals to 2x tangent inverse x minus ln x squared plus ln 2. Okay. So this one we can rewrite as ln 2 minus ln x squared plus 1. And using the law of logarithms, so ln a minus ln b, you get ln a over ln b. Okay. So we're going to use that. You just cancel this. Okay. Yeah, so we use this. You get y over x is equals to 2x tangent inverse x plus ln 2 over x squared plus 1. Okay, now just multiply both sides by x. You will get 2x squared tangent inverse x plus x ln 2 over x squared plus 1. Yep, so yeah, this is our final answer for this entire question. Okay, take one last look if you have to. Okay, I'll stop right here. Let's head on to the final question. Sorry, not the final question. Okay, so for this question, we are told that the matrix A is given by this expression. And for the first part, we need to find a matrix B and a diagonal matrix D such that A to the power 6 is in this form. So basically, they're telling us to express A to the power 6 in a diagonalizable form. So yeah, this is called diagonalization, right? So in order to do that, we need to know what we have in matrix P and matrix D. So matrix P will contain all the eigenvectors of A to the power 6. And according to our matrix identities, the eigenvectors of A to the power 6 is the same as the eigenvectors of A. Okay? And as for diagonal matrix D, it will contain all the eigenvalues of A to the power 6 in a diagonal, right? So according to the rules, the eigenvalues of A to the power 6 is just the eigenvalues of A raised to the power 6. So let's say A has an eigenvalue of 2. The eigenvalue of A to the power 6 would be 2 to the power 6. So I hope this makes it clear. And now we can find P and D. So let's find the eigenvalues and eigenvectors first. So to do that, we find A minus lambda I first. So that is 1 minus lambda 7, 11, 0, 2 minus lambda 5, 0, 0 minus 3 minus lambda. And now we have to find the determinant of A minus lambda I. So to find it, take this 1 minus lambda and define this determinant. So take the cross multiple of this, 2 minus lambda times minus 3 minus lambda minus 5 times 0, that is 0. Yeah. Okay. And then you take minus 7. And you take the cross product. Yeah, you see 0, so that's also 0. And then you take 11. you take the determinant of this one, it's also 0. So we can just leave it like this, and we equate the determinant to 0. Okay, right. So equate it to 0, then we get 1 minus lambda equals to 0, and lambda equals to 1. And we also get 2 minus lambda equals to 0. We get lambda equals to 2, and minus 3 minus lambda equals to 0. Then we get lambda equals to negative 3. So these are our eigenvalues. Now let's find our eigenvectors. So to find them, okay, let me just clear all this out. All these markings. Okay. All right. So minus, yep. Yeah, so to find the eigenvalues, we substitute the respective, eigenvectors, we substitute the respective eigenvalue into A minus lambda I, and then we take the vector product of any two rows, provided that they are not zero vectors or scalar products of each other. So let's first substitute lambda equals to 1. So you will get 1 minus 1 is 0, 7, 11, 0. 2 minus 1 is 1, 5, 0, 0. 3 minus 1, that is 2. Okay, so let's take the vector product of this as well as this. Yeah. So to find the vector product, you can just use your calculator. If you want more details, you can check out my further Pure Math 1 past paper solving videos for more information. If you want to know how to do it by hand, I'm just going to use my calculator. Please let me know if you want a tutorial on that as well. Okay, so 0, 0, 2. So vector A times vector B, you get 14, 0, 0, 0. And for eigenvectors, we should always simplify them. So this one we can easily just simplify to 1, 0, 0. Yeah, so this is our first eigenvector. Now let's find a second one by substituting lambda equals to 2. Okay, so substitute lambda equals to 2 into A minus lambda I, we get 1 minus 2, that is minus 1, 7, 11, 0. 2 minus 2, that's 0, then 5, and then we have 0, 0, 3, minus 2, that's 1. So as you can see, this and this, they are scalar products, so we cannot use these two, so we can only choose this and this, or the second one. Okay, so let's find the vector product of this. Yeah, minus 1. So almost about to write 1. Wait. Okay. So minus 1, 7, 11, 0, 0, 1, and is equals to minus 1, 7, 11, 0, 0, 1, vector A times vector B, you get 7, 1, 0. Yeah, 7, 1, 0. Can we simplify it any further? Nope, I don't think so. Yeah, so we can just leave the eigenvector like this. Now let's find our final eigenvector. So we need to substitute minus 3. Okay, so substituting minus 3, we get 1 minus negative 3, that is 4, 7, 11, 0. 2 minus negative 3, that is 5, 5, 0, 0. 3 minus lambda, so 3 minus, wait, oh, never mind. Oh, wait, minus 3, okay. Wait, oh no, wait, oh, okay. Yeah, so -3 minus 1, you will get -4. This is also, well, okay, -4. And this one, -3 minus 2, you get -5. Okay, so this one, you would get -5. Yeah, okay. Yeah, so -3, yeah, this is 0. Yeah, let's evaluate this eigenvector first before correcting the other two. So obviously we cannot choose this, so we can only choose this and this. So 4, 7, 11, 0, 5, 5. Yeah, that is equals to, just use your calculator. It's 4, 7, 11, 0, 5, 5. Vector A times vector B, you get -20, -20, -20, -20, 20. So this one you can just simplify to 1, 1, -1. And now let's correct these. Okay, yeah, just correct these all. So 5, 1, 3, 0, 7, 11, 0, 0, -4. So vector A times vector B, you get -28, 0, 0. So there's just 1, 0, 0. And then now we are going to -1, 7, 11, 0, 0, -5. So vector A times vector B, you get -35, -5, -0. And you just divide by -5, we get 7, 1, 0. Oh, it's the same answer. Yeah, so these three are our eigenvectors. Now we're ready to find out the matrix P. So matrix P, as I said, is just eigenvectors of a to the power of 6, which is the same as the eigenvectors of A. So to list them, you take the first eigenvector, list it like this, 1, 0, 0, 0, and the second one, 7, 1, 0, and then the last one, 1, 1, -1. So this is P, and now for D, to do this, you take all the eigenvalues. So we have 1 to the power of 6, because again, we're finding the eigenvalues of a to the power of 6, and yeah, a to the power of 6, so 1 to the power of 6, and then 2 to the power of 6, and -3 to the power of 6, and then the rest of the elements would just be 0. So you get 1, 0, 0, 0, 2 to the power of 6, you get 64, 0, 0, 0, -3 to the power of 6, 7, 2, 9. Yeah. So these two are our final answers for P and D, as well as the first part. Let's head on to the next part. Okay, so for this part, I'm supposed to use the characteristic equation of A to show this result is true, where A, B, and C are integers to be determined. Okay, so what do they mean by the characteristic equation? So it's this equation where we equated the determinant of A minus lambda I equals to 0. So yeah, first let's write that down. So 1 minus lambda, 2 minus lambda, -3 minus lambda equals to 0. Yeah. Okay, now we expand everything out. So -3 minus lambda, and then 1, 1. So we have minus lambda, that's lambda squared, minus lambda times 2, that's -2 lambda, lambda times minus lambda, you get minus 2 lambda, minus lambda, you get minus 3 lambda. And then 1 times 2, you get plus 2, equals to 0. Okay, now we multiply minus lambda times lambda squared, you get minus lambda cubed, and minus lambda times minus 3 lambda, you get 3 lambda squared, and minus 3 lambda times minus 3 lambda squared, yeah, you get 0 lambda squared. Okay, and then minus lambda times 2, you get minus 2 lambda, and minus 3 times minus 3 lambda, you get plus 9 lambda. So that's plus 7 lambda. And minus 3 lambda times 2, you get minus 6, all equals to 0. All right, so let's move lambda 3 to the other side. So you get lambda 3 is equals to 7 lambda minus 6. And let's square both sides. So this becomes lambda 6, and this one, just use your a minus b squared identity. So a squared, that's 7 lambda squared, so it's just 49 lambda squared minus 2ab, so minus 2, 7 lambda times 6, you get minus 84 lambda plus 6 squared, you get 36. Okay, and then now you can just replace the lambdas with a. Yeah, this is the main part. So a to the power 6, you get 49a squared minus 84a plus 36. Any constant term, just put I. Yeah, so yeah, this would be our final answer for this part of the question. Let's head on to next question. Okay, so for this last question, we're told that the curve C has this equation y equals to tangent x for x more than or equal to 0. So first part, they told us to sketch C and to state the equation of the asymptote. Okay, so if you don't know, the graph of tangent x, it's an S shape. So the asymptote here is y equals to 1, and here is y equals to -1. But however, they only said the only one for x more than or equals to 0. So we ignore this part, so we just sketch this part. Okay, so x, y. So this would be like this. Don't forget to label the asymptote. Y equals to 1. Y equals to tangent x. Yeah, so, oh yeah, we can also write here. Yeah, so this is our final answer for the first part. And if you cannot remember the shape of the graph, you can always do a table of values and then you substitute different values of x, like x equals to 0, x equals to ln 2, ln 3, and so on and so forth. Yeah. And then you would get like the general shape. Yeah. So let's head on to the next part. Okay, so for the second part, they told us to consider a suitable set of n rectangles of unit width. We have to use our sketch to show that this result is true. Okay, so the left-hand side, it is derived from the sum of the areas of the set of rectangles that we have to consider. And this is the area under the graph. Okay, so to do this, yeah, so the sum of rectangles is more than the area. So uh, yeah, let's say the rectangles would look something like this. Okay, yeah, so like this from 0 all the way until n. Yeah, all the way until n. Okay, yeah, so yeah, all the width is unit. So it's unit width. So the sum would be 1 times the height. The height is given by the function. So this, let's say it's 1. So tanh 1, tanh 1 plus 1 times tanh 2 all the way until 1 times tanh n, big N. And this is more than the area under the graph from 0 to n. So the limits will be n and 0, and integral will be tanh x dx. Okay, so this one would be r from equals to 1 all the way to big N, tanh r. This, the integral of this is same as sine x over cosine x dx, and 0, r equals to 1, and tanh r more than, yeah, so this one, if you don't know, it's actually in the form f prime x over fx. So when you integrate, you'll just get ln cosine x, ln fx, sorry. So hence, this will just be ln cosine x with limits n and 0. Yeah, so just substitute the values, ln cosine n minus ln cosine 0. So cosine 0, if you substitute into your calculator, you get 1. So ln 1, that's just 0. Yeah, so this would be a final answer. Yeah, we've shown, like they gave the result and we've shown it, so you should know it's shown. And with that, let's head on to the next part. All right, so now we are told that the arc of C joining the point where x equals to 0 to the point where x equals to half ln 3 is rotated through 1 complete revolution about the x-axis, and the area of the surface generated is denoted by S. So for the first part of this part, we have to use this substitution to show that S is equals to this. Okay, so first of all, let's sketch like a diagram of what they're describing. So they're saying the graph of C, okay, so like this, or from 0 all the way to this point where x equals to half ln 3, it's rotated about the x-axis, like through 360 degrees. Yeah, so now we have to find the surface area. So the formula for that is 2 pi y, the integral of 2 pi y times the arc length, which is given by 1 plus dy dx squared to the dx. And then the limits here would obviously just be half ln 3 and 0. So for this, you can think of this as the angle that is being rotated through, and this would be the height of the shape. So like this, and this is the arc length, right? This is the arc length. Yeah. So let's find our y. So y is basically just tanh x. So dy dx, you can check your MF19 under further pure maths. So tanh x is sec square x. Sec square x. And now we can write down the full integral. So in case you didn't know, you can like just take out the 2 pi and then you have half ln 3, 0, and then y is tanh x times the square root of 1 plus sec squared squared, so sec to the power of 4x dx. Okay, so this is our expression for s. Now we have to use the substitution. So yeah, let's do all the substitution here. So u is square root of 1 plus sec x to the power of 4. And then du dx, use the chain rule. So it's the power of half, and then you get half, you bring the power times 1 plus sec to the power of 4x to the power of half minus 1, you get minus half. And then times the derivative of 1 plus sec x to the power of 4. So that is just going to be 4 sec cubed x times the derivative of sec x. So sec x derivative is yeah, the same as the derivative of 1 plus sec cos x. So this becomes just 2. So 2 over square root of 1 plus sec 4x sec cubed x, and then this one becomes cos squared x, and then cos, oh my gosh, so very little space, and then you differentiate 1, you get this, and then minus you get sine, gosh, and then you would get minus sine x over cos squared x, and then this is just equals to tanh x, minus tanh x over sec x. Minus tanh x over sec x. So it's minus 2 sec 4x tanh x. Yeah. Yep, it is. Okay. Then over 1 square root 1 plus sec x to the power of 4. So this is du dx. Okay. So make dx the subject. Okay. All right. Okay, let me just put like a boundary here. Okay. Yeah, so dx. Goodness. All right. So now let's find the upper limit. So upper limit is square root 1 plus sec that is 1 over cos half ln 3 to the power of 4, right? You would get, oh, sorry, half ln to the power of 4 to the power of 4, yeah. Still syntax error. Wait a minute. Oh, okay, sorry. Yeah. Yep, you will get 5 over 4 as your limit. And then the lower limit, it would just be square root 1 plus 1 over cos 0 to the power of 4. You would get square root 2. Yeah, so let's write down the equation. So upper limit is 5 over 4 lower limit is square root 2. Yeah. You get tanh x 1 plus sec for x du dx. Okay, so we can make dx the subject, then we get dx is equals to the square root sec for x over 2 sec x to the power 4 tanh x du minus half. Okay. Yeah. And then minus 1 plus sec for x over 2 sec for x tanh x du. Yeah, so tanh x cancels out. Okay, and then 5 over 4 square root 2. And this one, okay, the minus sign can take out. I'll just keep it in, and never mind, let's just take it out for now. And this one is 1 plus sec for x over 2 sec for x du. So this one, in terms of u, it's just going to be u squared. And then sec 4 will be u squared equals to 1 plus sec x to the power 4. So sec x to the power 4 is u squared minus 1. So 2u squared minus 1 du. So 2 cancels out, and if you want to remove the negative, you can also switch the limits. So you'll get pi square root 2, 5 over 4 u squared over u squared minus 1 du. Yep, and that's the exact expression that we're required to show, so you can write shown. Yeah, so yeah, this would be a final answer for this part. Let's head on to the final part. Okay, so now they're telling us to find the exact value of this integral that we derived, and they told us to not simplify our answer. Okay, so to evaluate this integral, you can see it's a rational function, and both the degrees of the numerator and denominator is 2. So we have to first do long division whenever we have this case. Like whenever the degree of the numerator is more than or equal to that of the denominator, we always have to do long division before integrating. So let's do that. So u squared plus 0u plus 0. Then you have u squared plus 0u minus 1. You get u squared plus 0u minus 1. And this is 1. You get 0 minus negative 1, which is 1. So hence, u squared over u squared minus 1, you will get 1 plus 1 over u squared minus 1. Yep. Okay. And now we can split this up into partial fractions. 1 over u squared minus 1. So to split it up, you just factor the denominator, you get u minus 1 times u plus 1. Then you'll get a over u minus 1 plus b over u plus 1. Then you'll get 1 equals to a times u plus 1. plus b times u minus 1. So you sub u equals minus 1. This will become 0. So you only have b. So minus 1 minus 1, that's minus 2b is to 1. Then you get b equals to minus half. And then now you sub u equals to 1, 0. So you have 1 plus 1, that's 2. So you have 2a equals to 1. Then you get a equals to half. Okay. So yeah, 1 over u squared minus 1, we get half 1 over u minus 1 minus 1 over u plus 1. Yeah. Okay. Yeah, now we can start the integration. Oh wait, that's not 2 pi. Square root 2, 5 over 4, 1 plus half 1 over u minus half 1 over u plus 1 du. Yeah. Okay, so yeah, now we can integrate this. So to integrate, first integrate 1 with respect to u, get u, and then now integrate half times 1 over u minus 1. So you get half ln u minus 1, because it's in the form f prime x over fx. Yeah, so you integrate, you'll get ln u minus 1, then minus half. This is also in the form f prime x over fx. You get half ln u plus 1. Square root 2, 5 over 4. Okay. To make it simpler, let's also simplify. So we can factor out the half. Then you have ln u minus 1 minus ln u plus 1. So you get ln u minus 1 over u plus 1. Square root 2, 5 over 4. Yeah. So that's good. Square root 2 plus half ln square root 2 minus 1 over square root 2 plus 1 minus 5 over 4 minus half ln, okay, 5 over 4 minus 1. Wait, 5 over 4, okay, so 5 over 4 minus 1 over 5 over 4 plus 1. You get 1 over 9. Okay. Then you will get pi square root 2 minus 5 over 4 plus half ln square root minus 1, square root minus 1 over square root 2 plus 1 minus ln 1 over 9 bracket. So this one you can simplify. You will get pi square root minus 5 over 4 plus half ln square root, you will get 2 minus 1 over square root 2 plus 1 divided by 1 over 9. So that's the same as times 9. So you would get 9 square root 2 minus 9 over square root 2 plus 1. Yeah, and we can actually stop right here because the question said you do not need to simplify your answer. So yeah, this would be our final answer for this part. If you want to know whether your answer is correct, you can just type this exact integral into your calculator. So I'm just gonna do that real quick. Okay, so it's x squared minus 1, 5 over 4, square root 2, Actually, yeah, let me just, okay, pi. All right, let's see what we get. Okay, we got 1.198367763. Let me see if that is equal to that exact value. You guys also can check alongside me. Square 9 square root 2 minus 9 over square root 2 plus 1. Yep, I got the exact same answer. Yeah, so yeah, this is our final answer for this part, and we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future past paper solving videos of A-level maths and further maths, as well as topical tutorial videos. If you have any questions or doubts or any queries or any feedback on any future video ideas, whatever it is, you can leave it down in the comments below. I will try to reply as soon as possible. And please head over to the posts tab on my channel and check out the latest posts where I'm offering tuition for A-level maths and further maths. And with that, I'll see you again next time. All right. Thank you.